Hello and welcome to my session, AI Augmented Testing. AutoOps, harnessing the power of AI augmented testing with generative AI. So a quick introduction. I'm known as the Automation Cyborg by Joe Colantonio, sent back in time to help save the world from bad software. If you want to find out more, just go to Jonathon.ai. You can have a chat with my AI assistant. So let me just talk a little bit about the journey today, and for those who've not heard of Keysight. Keysight are originally Dave and Bill, all the way back in the garage in 1939. You know, part of it is they were the birth of Silicon Valley. They're also the first to do build and test, so this agile development. And so, you know, a little bit around that journey from Silicon Valley to where I am at the moment, which is a few miles away from Bletchley Park, which is where famously Alan Turing wrote and published his first papers on the singularity. So really interesting is the foundations of what we're going to be talking about today, which Gen AI is in essence a subset of artificial intelligence, machine learning, and then Gen AI. Okay. So this journey, and you probably saw my last talk definitely back in 2022 and 2023, I started talking about generative AI, but prior to that I was talking about the metaverse and Web 4.0 technologies. So this is things like the new Apple Reality Pro. It's also things like 6G and Wi-Fi 7 connectivity, so a lot around the RF space, and really looking into the future of what does that mean. So Web 4.0. You know, okay, it sounds like a bit of a buzzword, but really it's bringing all of the technologies which I'm going to be talking about today together. So things like generative adaptive networks, which you've seen before, such as DALL-E, and really good at creating images and fooling kind of humans on kind of capabilities. And then of course today we're talking about GPTs, generative transformers, which again are kind of the capabilities which really unlock large language models. So again, this journey which we're talking about today, we're going to be focusing on the artificial intelligence kind of component. We're going to explore some of those terms, but we're also going to see how we've actually implemented those in the real world and made those available into a real product. So, you know, beyond the kind of I guess, last year, which was the year of, I guess, hype, you know, you could talk about generative AI. I think everyone was talking about generative AI, but there was only a few companies that were actually building capabilities, mainly wrapped around things like OpenAI. And I would definitely see that change this year. This was kind of the prediction, is that actually, you know, you should not be exposing any of your IP to an external facing generative kind of capability, because you know there's concerns around privacy and data leakage, but also I guess when you're looking at things like the new EU AI Act, which has just come in force, you know, there's massive potential fines, much greater than GDPR. So building on this, what was very hype kind of industry, we've seen organizations like Gartner, who I spoke to just the other day, who have also looked at putting things like prompt engineering, and more importantly today around AI augmented testing, right at the top of the Gartner wave. So this kind of indicates just how prominent it is within the industry at the moment, but also I suppose it directly correlates to the level of interest. So I'm going to be talking about these kind of capabilities today. And there's a range of them. You probably heard things like Zuckerberg, you know, ordering 250,000, AI NVIDIA cards, T100s, so that he can build a general artificial intelligence, you know, but many, many years away, all the way down to what I'm going to be exploring today with you about things like graph neural nets, and some of the capabilities which you need to be thinking about to really realize the value within AI augmented testing. So I think the big takeaway, and it's kind of the main message, is around that you're not going to be replaced by an AI, but you are going to be replaced by an AI and a human. So, you know, this is where we need to now think about how do you leverage the technologies we're going to talk about today, so that you can have superpowers and keep yourself up at the pace of the rest of the test industry. So again, this has been highlighted. I put AI in the loop because I think part of it is there's two modes. There's tester in the loop on one side, which is where you're primarily using this to interact with and build and get capabilities. And then there's also a job for AI in the loop, which is kind of more looking at maybe reporting and analytics and feeding you back suggestions about things maybe that you've missed and capabilities that or things you should be doing, the next best test, shall we say. So very much this unfortunate clippy reboot this year around virtual assistants. So we've seen the demand, and we actually was part of commissioning this IDC report, which talked a little bit about kind of the use cases and where we're going to see the technology potentially being unlocked within the AI augmented testing landscape, and what are those potential use cases. Again, I'm going to be going through those today. So let's start getting into it. And first of all, I wanted to kind of set up the challenge statement, right? I kind of wanted to say, well, what's the problem statement and how are we going to address that problem? And so first of all, again, I spent a bit of time with Diego from Forrester last year. And again, he was showing me the numbers of the industry average for test automation. And it's still around 20%, actually 22% to be exact. And this hasn't really increased since probably the 90s and the noughties, or even this century, shall we say. It's not exponentially increased. And I think that's two things. One is it's difficult to get that level of coverage, enterprise-wide coverage. You might be saying, oh, well, I've got 100% or I've got 70% in my project, but we're not talking about everything across the entire landscape. The second thing is that new ways of working, DevOps, post-IL methodologies such as Shape, really now focus on continuous delivery and adding value driven testing continuously. And that's quite hard to keep up at that level of pace. The same accelerations that GitHub Copilot have seen, which is about 7% efficiency and productivity increases, you're probably going to see similar kind of numbers. So it's not game changing, but you are going to see a definite increase with Tester Copilot. Is something we're releasing later in this year when we launch our IDE version within Visual Studio, which is actually now available in the marketplace on early preview. But we're going to add in those code generation capabilities as well later this year. So what is it, what we're doing? Well, I would say that most people in the industry, definitely including myself over the last 25 years, have focused on automation as a potential way of helping provide savings on time for testers. But, in actual fact, it's always been focused on what I remember back in the 90s. I put in a book with Dorothy Graham around, manumation, or what I was calling manumation, which was this idea that you have to do the manual effort first before you can automate anything. Therefore, why don't you capture it at the time that you're actually executing and create a model out of it? But, years on, really, we've still been led by the manual effort needing to be the primary upfront effort. And typically, it's over 50% of the time is spent taking and understanding, say, for instance, requirements, and then generating tests out of the back of it. Now, automators have been focusing on taking those tests and then creating automation after it. So they've already the hard work's been done. Really, all they're doing is just replicating or creating automation to map against existing test cases, which isn't very valuable based on even back in the 70s, 80s, Dorothy was kind of saying that actually the likelihood of finding an issue once you've already been through that path is next to nothing. So, are we investing in the right time? And I would argue that, actually targeting test design instead of the test execution is probably going to be the biggest savings in a kind of this kind of new modern ways of working and keeping at the pace of things like DevOps. So, I'm going to go through this in a little bit more detail, but I think ways of working is probably a great way to start. And back in 2015, I wrote a book around multimodal delivery mechanisms, and part of that was this kind of concept that you've got multi-modes, typically 3, but that could be much more. The first one is your kind of your traditional, I suppose, waterfall V model which or engineering-based projects, which is what we call core IT, and that's fine. That's kind of, there's typically a split of about 60% of organizations' projects are in that core IT. And the reason why is, yes, they might be the newfangled development processes, but typically it's keeping the light on. And this is where we see, IT operations being a large part of businesses who are still running on those ITIL-v4 processes and service management techniques that are a little bit longer and and incident management life cycles, right? Which are, again, still quite long. And then we move into kind of the next area, which is this kind of this fluid IT, kind of this push towards, okay, let's start moving into agile and scaled agile and safe and DAD and less, all these different methodologies around scaling the ability to release much faster. And of course, this has been great. There's been a bit of an issue, which is the misinterpretation of the Agile Manifesto that states, working software over documentation. What it's actually saying is, if you read it at the bottom, it says, we value the stuff on the right, we just value the stuff on the left more. That's great, but that's not saying no documentation. That's saying that actually we prefer a working product, which is fine, but you still need to document. You still need to express some way of shared expression of what you're actually doing, what the teams are working on, etc., etc. And then there's this new mode, which probably represents about 10% projects, which you could see as the lean UX, fail fast, rapid prototyping areas where, it's not in a sprint cadence of 2 to 6 weeks, it's actually more in days, hours, seconds, and I think that's, where we are today with small projects that, you've got to learn and fail gracefully and fail quickly. So three modes. In essence, there's obviously probably more. I'm not going to add in that that's the only way to do ways of working, but I'm going to take those. I'm going to walk through each one of those flows and try and express where you can benefit from generative AI, no matter what you're doing. So let's just start with this kind of the SDLC, right? And SDLC is still a very small segment. It might feel like we're in, the main bit of technology, but actually, if you look at the wider information technology landscape, and you even then include the business aspect or business technology, bringing the two together, or product engineering, bringing product and engineering together, actually, suddenly we're dealing with lots of teams, and typically what you see in the current model is you're having to communicate and update all of those teams, and that's a very, I call it the digital grind. It's sending emails and communicating with other stakeholders, getting on calls for the sake of calls, whatever it may be. And then you've got this new mode, which is there's a single pane of glass, single source of truth, which is this is a business analyst has expressed a model which has been validated by the business. It's been validated. That's what the customer wants. And if it changes and it amends, the model changes. It's a very much like a digital twin where you've got a working software model on there that's an entity. It's a living thing. Again, we're a long way from one side to the other, but this is this journey that we're on today. So, again, I mentioned back in the 90s, I kind of remember taking this on the right-hand side from Dorothy's book on test automation patterns, and part of it was you look at it and it's very simple. It's kind of trying to say, well, actually I spent if on average you spend 30 minutes in test design, it's going to take you twice as long to do it as an automation script. That's just an indication. We're not saying that's exactly what the truth is. We're saying typically you're spending twice as much time automating it as you would to actually design it. Again, if we take this flow here, we're saying indicatively over 50% is in part of the requirements, going through, understanding the requirements, then going through and doing the test design, and then from the test design, the actual test creation. It's a huge amount of effort, and typically automation tools will focus on this last segment, on test execution, test maintenance. And yes, there is, if you look at the numbers, it might take 10 minutes for a manual tester to do something. It might take 2 minutes for an automation tool to do checking of a similar kind of process. But still, it's a very small segment, small percentage. And then we all know, 3-4 decades into automation, that actually test maintenance is the biggest problem. And that's ended up rewrite. That includes redesign, the redesign phase. So massive problem. And we're saying that over 50% of this effort is probably test design, right? So, I could straight away kind of do the downside of all these, kind of slides is kind of go, well, these are the savings you're going to get. If you're aiming for 50% of test design, then that's 50% potential benefit you could get, up to 50%, The next one is you could say, well, test maintenance is a serious problem, and having computer vision combined with enterprise grade OCR and digital twins and self-healing and all these kind of great technologies, you're also going to reduce some of that, but you're also going to reduce the time for the redesign period of is that test still valid? Are we just fixing flaky tests? So again, second component, but something we could potentially really add some value in. And then finally, on this right-hand side, we're saying there's two things. First, we're able to keep up at the pace of DevOps, so we're actually increasing by reducing the test design phase. We're potentially increasing 10 times velocity of throughput. So massive benefits there. And then you could just add in the standard 22% coverage where the industry is, trying to get 50% increase in that, again up to that magic 74% or whatever it may be, is the point of diminishing returns. Again, something we can really add benefit. But let me kind of take you through that in the sense of, I think it's really hard to kind of say, look, you can download this tool today, which you can, and get these benefits. And in actual fact, I think you're better off grabbing, starting your journey off in this kind of manumission landscape, start maturing what we refer to as the synthetic human, going through paths, discovering paths, understanding systems, and then move over to a higher AMMI, automation maturity model. Now, I published this back in 2003, and yes, it's evolved slightly in the sense of when we're talking about sustaining and optimizing, we're really talking about predictive ALM, we're talking about next generation quality stream management and really next generation capabilities, but the concepts are still exactly the same. So let's go back to the 70s, 80s with people like Tom Gilb and requirements engineering principles. And Tom put together Planguage, which was a unambiguous language based on quite maths, similar to Klingon, which allowed you to be able to avoid the misunderstandings that you get with English, which is great for poetry, but not great for specifying business requirements. People like Eric Simmons' principles around requirements engineering, Dot looking at things like document inspection around how do we check at different areas and also test to make sure we're testing much earlier. And I call this shifting very left or even shifting up to the business, because you're having to catch things not from an SDLC perspective, but beyond into the PLM kind of product lifecycle management kind of landscape. But these handoff points, obviously, there's more, you want to catch things earlier, it's going to obviously have massive benefits of savings, but still miscommunication can happen at any one of these points. So how do we change this misunderstanding, right? And if we just take the standard flow on the right, which is very simple, you might take requirements and then, you might look at them and go, okay, I'm going to start creating, and if the end goal is, say, some tests, that's great, but what happens when the requirements change, or if they ever get signed off? This might be 50, 60 different changes. The example I'm going to give you is a document that we fed in from the DoD Department of Justice that we talked about, a declassified NATO document in this particular example, which was hundreds and hundreds of pages with hundreds and hundreds of changes that were made through that document's lifetime. How do you update the tests as soon as the requirement changes, or even know what the requirements or test impact of that is? So actually wrapping your requirement around tests and that holy trilogy of test, requirement and code, how do you link those together so if the code changes, the requirement is told that this is going to make an impact, or the test has to change? Even those basic principles, we're still following a very simple workflow. So that's the first one. And then the next one is really about how do we build within these new ways of working. So I started off with the requirement side of things, moving into testing, the testing landscape, and then all the way through to operations and then that feedback. This is quite a complicated area, but actually that life cycle is something, again, where you're handing off at different points. And really the benefit can become, is around keeping those two components together. So for agile practices, scaled agile safe, This is really important, and understanding this entire continuous feedback. And then what we see on the left-hand side is how do we bypass that from idealization, which is the business saying, we should do buy one, get one free on pizzas, or buy two and get one free because it's changed again to another offer, to, it quickly entering some kind of agile backlog kind of Kanban or, other type of board, right? So, take that and then look at that exact same flow again, right? You've got, in essence, it's still the same thing. You've got requirements that are feeding into these sprints, and you're creating test cases. And again, even though the terminology is the same, and in slightly different in sometimes, it's the same process. And the difference is to that kind of working software over documentation is that the documentation's less. I'm not feeding in a 100-page document anymore. I'm feeding in some requirements, maybe some sprint planning session and some review of trying to understand and really get to the bottom to what does this feature do. But still, lots of communication, lots of areas that it could potentially go wrong. And then, if we take this again to break that down into a single sprint, again, there's all these different iterative kind of builds and tests and areas. And actually the time to quality is typically pushed to the end of that sprint. And then you can't sprint all the time. Typically, you don't really raise defects in sprint. So you have no gauge of quality, and in essence it could be multiple sprints and iterations before you even get to the point with something that's really working software to a certain level of quality. So really quite difficult. So again, let's take that same flow. The difference is we've got sprint planning, maybe we've got retrospectives, we've got all these different areas, but still the information flow and sprints and sprints of sprints, really make it much more complex, right? So I call this kind of very chaotic compared to maybe well-structured engineering practices, but of course they're much slower to deliver. So let's kind of talk about the solution, right? Back about, it was probably over a year ago, I started talking to Paul Gerard. We did our first session around that. We've been working on tester GPT. Could we create a version specific to testing? And very quickly, I think even on that back in March last year, we were talking about the fact that this would have to be offline. Public-facing API, Gen AI solutions, I think, are probably going to be, wiped out by the EU AI Act in one way or another. And you might say, okay, well, that's great. I've got Hugging Face, Azure, or I'm using OpenAI on Azure, and I'm a lot more happier with my security policies and stuff that's inside my own private cloud, that actually I'm going to be able to just deploy that as part of what's Copilot's going to be pretty much Windows 12, as long as you've got 16 gig of RAM and enough for the model to sit in. But I think part of it is, yes, that's fine to a certain level, but still you need governance around this. And typically what we found, especially from our customers who want to be able to kind of air gap this, they don't want to be connecting these systems to the internet. They don't want to be sharing very sensitive IP with potentially, over the internet. They want to be able to do everything locally and be able to control their generative AI. Then really this is kind of the only way you can do it. And of course, if you're still in the new ways of working, you can deploy this on your laptop, right? There's flexibility, or you can put it into the cloud. You can build it into AI infrastructure that will actually take advantage of the DPUs, the dedicated processing units, or even GPUs. If you're using some CUDA kind of farm, you can bring all this to any kind of setup you potentially want. But really what's important is we're creating what we've, previously called the synthetic domain expert, because it was one of those I know everything about your organization. I'm learning all your documentation. I'm reading through your Confluences. I'm going through SharePoint. I'm pulling documents of sources of reference in there. And I'm really starting to understand your project, or even multiple projects. If you've got lots of teams that are all working on front end, back end, e-commerce, or even to NASA kind of space shuttles, different divisions, etc., etc. So really quite comprehensive. But we're creating this AI augmented testing that does two things. First is it creates tests and test assets. So you've got things like your manual test scripts. So if you're thinking about an entire manual process here, you can still do the test design and create test scripts through this process. You can create, of course, automated scripts. You can create models of the system. You can create executable specifications, so things like Gherkin if you really wanted to. Part of it is it gives you that flexibility of wherever you are, whether you're in those 3 different modes, you can generate assets that you can use straight away. So let me kind of explain how this works, because I know it sounds like it's very futuristic and maybe you're kind of asking the question around things like trustworthiness, but also you're probably asking the question around the sheer complexity. And I think this diagram here really helps with that, in the sense if you look at it, you've got data. Data's just raw information, no real structure. I kind of class it as unstructured data, but really this is the problem we've had with big data and everything else, data lakes, whatever you want to call it, is you're storing huge amounts of data, but you don't really turn that data into information. You don't really kind of be able to collate that and categorize that and move that from unstructured to structured. Now, once you've got it in a structured and you've got some kind of meta understanding of the data sets that you've got, you can then turn that into knowledge. Now, what is knowledge, right? Knowledge, in essence, is the linking of information. So this is me understanding the relationship between X and Y. In the example of what the tool does, for instance, when you put in a requirements document, it'll ask, as you'd expect it to, for definitions. It'll say, well, what is this, expire token rate, ETS? What does that mean? Because I've got a definition for ETS based on some IEEE, ISO testing terminology, or some ISTQB, or maybe some industry-specific IEEE automotive or aerospace and defense terminology, but I don't really understand it in the context of how you use it in your organization. So at that point, you would then build the relationship between the 2 nodes to say, actually, it means expired. This refers to, in essence, a process and an application layer, and you're expressing that information so that it can do understanding. Once you've got that level of understanding, then you can turn knowledge and knowledge workers, which means that you don't always need to have somebody who's a single point of failure who knows all of the systems. You can bring that knowledge with you. So it sounds really complicated, and part of down here at the bottom is around wisdom. Wisdom is a human trait. It's not an AI-based trait. So it's you augmenting the AI to help human in the loop or tester in the loop to then say, well, actually, automotive blueprints, but maybe there's some information, the path that you've taken that joins a lot of nodes together that you've seen over and over again. You bring that to the package. So it's not just the AI doing everything, it's helping assist you on that level. Very similar to the AMMI maturity model. The next thing, which I kind of expressed, is the first mode, right? So we said about requirements, and so you can see here the pages from the NATO document. You can also see here the ISO documentation around requirement specification documents and what should the format be. So what we're taking is that entire document actually in PDF format. So it could be PDF, it could be document, it could be it could be in Excel, right? You could have exported that out and put it into some kind of better notation with structure in. But in essence, you're taking whatever document or structured or unstructured format you've got and feeding those documents in, those sources of knowledge, the sources of reference. All that information goes into the system, and then that's used as part of the GNN. So I want to talk a little bit about the graph neural net and how we're building. We're using a RAG, a retrieval augmented generation capability, which does relative generated answers as well. So that gives you the ability to ask questions about documents, ask questions about domain-specific questions, very similar to the kind of what you would get from a normal prompt engineering or prompt tuning kind of exercise using Jupyter Notebooks or something. So let's just quickly go with the difficult one, which is natural language processing, right? Natural language processing is in essence within is a way of semantically reading and understanding the document context, but also you've got natural language understanding, which is then understanding the language which you've just pushed through the system. And that's understanding that actually that time to token or whatever it was of acronym, it doesn't understand. So it needs to be able to understand for it to be able to then be able to respond back in the correct way. So this is a bit of a spoiler alert, but the spoiler alert is, in essence, this, the large language models aren't the important part of this. Even though you might think generative AI and generative AI equals large language models, actually it's just a component, right? If we see the picture behind, which is the normal software-defined vehicle kind of landscape, that actually, the engine component could be quite easily swapped out. So you could have a big engine if it's a big kind of V12 or something, or you can replace that with your diesel 2-litre. It'll still work, the car will still drive. You change the suspension and all the different handling components, it's still a luxury or a nice car. You just can change the language model in and out. So we use typically 2 large language models at a time simultaneously for different types of tasks, but also, we could have a 7 times 8 billion, so that's like more of your 50 gig primary memory kind of use case, which isn't on a normal laptop. Or you can live with kind of what Copilot does, which is the 8 billion kind of variant, which might be able to fit within your GPU, or it might even fit into your normal memory if you've got a 16 gig laptop. Part of it is we built this that it'll run on consumer hardware, it'll run on your Mac, it'll run on your standard laptop, but it also will be able to scale up. So if you want to use bigger models have better understandings of the world, you can swap those in and out. But in actual fact, you've got to think of all this other stuff that sits around it is actually the magic sauce that we've had to build. And quite a lot of why OpenAI is so valuable is that it does a lot of this, a lot of the function calling to understand schemas and etc., etc. That's what, OpenAI have built on top of their large language models, which is why taking a large language model like Llama and then just trying to use it doesn't really add any value. It definitely doesn't add that much value when it comes to testing. So how does this become valuable? Within that is the knowledge graph, right? Knowledge graph is the first component, and we have multiple knowledge graphs. We have knowledge graphs of testing terms from terms.tkbbase.com, and the work that Paul's been doing. We have all of the IEEE, the ISO, the ISTQB, all of that information's there. It knows testing. Now I say this in the same way that Neo knows testing, right? He knows Kung Fu, right? He kind of downloads it, he knows Kung Fu, but he gets beaten by Morpheus. And that's because Morpheus also knows Kung Fu and the same amount of variance, but he also has that wisdom, that extra information that's been augmented on the top. That's what we've done, is we've built it and fine-tuned our model to be better at testing, but also not just testing. The graph representations are also industry specific. So this then brings into business analysts and ITIL and print too, and all these different other kind of surround tertiary kind of disciplines, should we call them. But it also is happy at the content sensitive camp, where they could say, well, actually, it needs to know automotive, it needs to know 6G, 3GPP standards, it needs to know everything else about a particular industry, financial services, derivatives, FX, whatever that might be. So you can choose how these graphs, these knowledge graphs are interacted with and built, and then you can also customize them. The idea is it's going to build one for your company, which is your unique, in essence, knowledge graph, and then you're going to customize it. You're going to then say, actually, that relationship between the token and something else is incorrect. So you're building a Domino's or an Intel version of what your model looks like. So again, there's multiple models, and this really then feeds into the graph neural net, which allows it to do reckoning of questions with much higher accuracies than you're going to get from a traditional GPT model. And so let me quickly explain how that works, right? Is the RAG architecture that I just mentioned, and you can probably see some of the kind of the ways that the single shot, multi-shot kind of approaches would do, is in essence we're taking 3 different stores. We've got the vector store, which in essence is just a huge data store, and this is what you've probably seen in GPTs is, oh, here's a document or here's an image, read it and understand it, and then I'm going to ask you some questions about it. That's the same thing within the vector. It's just in essence short-term to long-term memory support. Next thing is the actual vector, the vector database and then the graph database. The graph database, your Neo4j, whatever graph representation you're doing, and your GraphQL, whatever you interface it with, part of it is it's understanding that model and multiple models. It's not just a single model. In this case, it's taking your documentation, your sources of knowledge, and feeding in essence, the testing documentation into the vector, the testing strategies and all the tertiary information into the knowledge graph, and then using those RAG retrievals to actually get the information out in a kind of a very prompt tuning kind of landscape where you're going through and there's 9, 10, 12, transformations in essence but happen for every single question that you're asking. So it's quite a lot of work, a lot of kind of back-end magic that we've had to do. Equally, what we're able to generate with we think of the executable specifications, we think about test models, so things like digital twin definition language, XPDL, extendable process definition language, business process modeling notation, all that, plus any types of tests, manual tests in any type of format, test automation scripts, that might be Playwright. Of course, we've gone with SenseTalk because it's a natural language, it makes it a lot easier, but it gives that level of flexibility, Selenium, etc., etc. So really providing flexibility of output as well as input. So again, output, input, what does that look like, right? And so I've kind of taken an example. You can see here, we've pulled in some documents and it's generated some manual tests, right? So it can generate manual tests, it can generate the executable tests, it can generate SenseTalk scripts, whatever you want in. In essence, it's just information output that we're doing, and that can be regenerated. So if things come into this system where there's changes to the requirements, you can regenerate all of your tests and tell you which tests need to be updated, which code needs to be updated, etc., etc. So bringing in that holy pyramid, which is really quite difficult to manage. Okay, so the final kind of couple of slides here that you see here on the standard flow is that we're taking requirements of any flavor of 3, in essence, modes. We're pushing it through the translation area. So this is the first human in the loop activity. You can see here we're running 2 separate models at the same time. One is dealt with is instruct, which is very good at language interpretation, so we use that. Then we've got a variant which is used for code generation, which has actually been fine-tuned on our code generation, but of course we can fine-tune that against anything else as well. But in essence, these different touch points will use different large language models, we use different technology approaches to be able to take, in essence, refine requirements to tests. And then the next step, you'll see a whole list of tests. It'll give you a scoring rating. It'll tell you from a risk-based testing which ones to run first. It'll tell you the justification behind them, the value of each test. It'll obviously do deduplication. It'll do test case optimization. It will, and you can ask it to regenerate certain ones or whatever else you want, and then you can generate the assets and go through this workflow like you would normally do on your daily job. Or as a side thing, you can do the prompts, right? So, we can run just in Visual Studio code, for instance, and just directly connect with Jupyter Notebooks and just ask it questions, right? So yes, there is the traditional prompting chat capability, which I think everyone's used to when they think about Tester GPT, but that's not the primary method. That just is a way of, in essence, being a developer and using the API to then say, actually generate me some Appium scripts, or generate me some Selenium scripts, or do this, or what is this? These 2 duplicated. Find all the similar requirements. Show me the requirements traceability. You can do all of that and directly interact with it. And both on the web page, the SaaS-based solution or the on-premise container, or also just directly in from the API. So finally, on to the last slide, you can see how we pull all of this together using adding the real value of AI augmented testing on the top, all the way down, human in the loop, AI in the loop, really pushing in generation of assets at any level, API, component, UI, you name it, we can generate it all through the new Eggplant Generative AI platform, which is actually available for early access today. So you can, sign up today, start downloading this, and start getting some real value. So with that said, and I'm going to go back through again just in case there's a non-sell version of it. Okay, on to the final slide. This just summarizes it. With this, I'm going to kind of start taking some questions to talk about how this new architecture of really adding the value-driven testing at the top with a tester in the loop, and then at the bottom, all of those capabilities that can generate UI, API, component, whatever types of tests you want, manual tests, exploratory tests, accessibility tests, security tests, whatever you're wanting to generate, you can now have the flexibility, and this gives you superhero powers. So this is the new AI augmented testing platform, and it's going to enable you to be even better than you already are. So let's open to some questions.